we are moving to our next topic, uniform motion and non-uniform motion. Uniform motion and non-uniform motion. If an object covers equal distance in equal interval of time, equal interval of time, then the motion of object is said to be uniform. Uniform motion. If an object covers equal distance in equal interval of time, then the motion of object is said to be uniform. That means the object is covering same distance in same interval of time. For example, if the object covers 10 meter in 2 seconds time, initial condition. Again, after next 2 seconds, the object should cover another 10 meter distance. Again, after 2 seconds time, the object should cover another 10 meter. That means for every 2 seconds, the object is covering 10 meter distance. This is continuing throughout. It doesn't changes according to time. For every 2 seconds, the object is covering same distance. If this continues like a pattern, that means for every 2 seconds, the object is covering 10 meter distance. Then we can say that the motion of the object is uniform. I'm just taking the example as 2 seconds time and 10 meter distance. Like that, whatever the time may be and whatever the distance may be, the only condition is that for equal interval of time, the object should cover equal distance. Then we can say that the motion of that object is uniform. That's what called uniform motion. That's what called uniform motion. If an object covers equal distance in equal interval of time, then the motion of the object is said to be uniform. That is uniform motion. Now we are looking to non-uniform motion. How we can explain non-uniform motion? Non-uniform motion. In uniform motion, we explain it as the object covering equal distance in equal interval of time. That means it continues like a pattern. For example, I wrote in the table that for 2 seconds time, the object is covering 10 meters distance. For another 2 second time, the object should cover the same 10 meter distance. Again, after another 2 seconds time, the object should cover the same 10 meter distance. and this continues like a pattern. And such motion are called uniform motion. But in non-uniform motion, we cannot say that the object is covering equal distance in equal interval of time. It may vary, it may change. For example, when we are driving a vehicle, we drive according to the traffic signals or traffic block we get in our road. That means we are riding through a road. If there is lot of traffic jam or traffic block, we just slows down. If we are getting red signal in traffic, we just stops. That means we cannot maintain a constant speed in our road. It is just varying. If we get a road where there is no vehicles, a free road, an empty road, then we can accelerate and go. Then we can speed up and go. That means in our road, we cannot maintain a constant speed. It may vary according to the conditions. Therefore, at that time, such motion can be called as non-uniform. We cannot cover equal distance in equal interval of time. If we are covering unequal distance in unequal interval of time, then the motion of object is said to be non-uniform. If the object is covering unequal distance in unequal interval of time, then the motion is said to be non-uniform. If an object covers unequal distance in unequal interval of time, then the motion of object is said to be non-uniform. Now we just deliver the difference between uniform motion and non-uniform motion. Just rewind it in your mind. What's uniform motion and non-uniform motion? In uniform motion, the object is covering equal distance in equal interval. Equal and equal. Just store it in your mind that equal and equal. Equal distance, equal time. Then the motion is uniform. Unequal and unequal. That is unequal distance in unequal interval of time. Then the motion is non-uniform. That's the difference between uniform motion and non-uniform motion. Now we are going to the next topic, the difference between speed and velocity. Just as the same way we differentiate between distance and displacement, we are differentiating speed and velocity using a table. I am now constructing a table to point out the difference between speed and velocity. Speed and velocity. First of all, we have to define what speed is and what velocity is. You need to understand what basically these terms mean. The term speed and the term velocity. Speed is defined as distance traveled by an object in unit time. Speed is defined as the distance traveled by an object in unit time. If an object traveled 50 kilometers in 1 hour, just think if an object traveled 50 kilometers in 1 hour, then the speed of that object is 50 kilometers per hour. 50 kilometers per hour means in 1 hour, the object can travel 50 kilometers. Or 100 kilometers per hour means in 1 hour, the object can travel 100 kilometers. In other words, we can say it in meter and second. If an object is traveling 10 meter in 1 second, then we can say the speed of the object as 10 meter per second. That means the object can travel 10 meters in 1 second. Therefore, speed simply means that the distance traveled by an object in unit time. The distance traveled by an object in unit time. This is the speed. Now moving to velocity. Velocity is the displacement of an object in unit time. That's the only difference. In speed, it is the distance in unit time, but in velocity, it is the displacement in unit time. Now you are already aware of what the difference between distance and displacement. Then we can simply understand the difference between speed and velocity. Speed is the distance in unit time, while velocity is the displacement in unit time. The displacement of an object in unit time, that's the velocity. First point of difference. We define the speed as distance traveled by an object in unit time. Therefore, speed can be written as speed is equal to distance divided by time. It can be written as speed is equal to distance divided by time. Likewise, we can write velocity as velocity is equal to displacement by time. Speed is equal to distance by time and velocity is equal to displacement by time. We write speed as an example of scalar quantity. Therefore, we can say that speed is a scalar quantity. Also, we write velocity as an example for vector quantity. Therefore, velocity can be a vector quantity. Is a vector quantity. We already know the characteristics of scalar quantities and vector quantities. A scalar quantity cannot be zero or negative. Therefore, speed cannot be zero or negative. speed cannot be zero or negative. Since velocity is a vector quantity, it can have all values, and a vector quantities can have zero, positive or negative values. That means all values. A velocity can have zero, positive or negative values. Now we need the unit of both these quantities, speed and velocity. From this equation, speed is equal to distance by time. Using that equation, we can easily find the unit of speed. Unit of speed is, look here, in this equation, speed is equal to distance by time. Speed is equal to distance by time. We already know the unit of distance as meter, by unit of time is second. The SI unit of distance is meter, and the SI unit of, that means standard unit of time, is second. Therefore, unit of speed is meter per second. And by using the equation of velocity, we can find the unit of velocity. Here, look at this equation. Velocity is equal to displacement by time. We know that unit of displacement is meter and the unit of time is second. Therefore, meter by unit of time is second. That is meter per second. Look, the unit of both these quantities are same. These are the difference between speed and velocity. If you are getting a question, differentiate between speed and velocity, like what we have said in difference between distance and displacement. You can construct this table. This is simply the difference between speed and velocity. Just look at the table. Speed is the distance traveled in unit time, and displacement is the, velocity is the displacement in unit time. Speed is a scalar quantity while velocity is a vector quantity. Unit of both these quantities are same, meter per second. This is the difference between speed and velocity. Now look at this table. I think it's clear to you the difference between speed and velocity. Now you understand what the difference between speed and velocity. Now we are moving to our next topic, average speed and average velocity. Average speed. Average speed is defined as the ratio of total distance to total time taken. It is the ratio of total distance to total time taken. That simply means when total distance divided by total time, we get the average speed. To find the average speed, we have to divide the total distance by total time. Average speed is defined as the ratio of total distance to total time taken. That means total distance when divided by total time, we get the average speed. Therefore, we can write average speed equal to total distance divided by total time. This is what average speed. Need not be confused. No confusion. We are having two terms, average speed and average velocity. Just focus on your study. What average speed is? Average speed is the ratio of total distance. Just note the point. It is the ratio of total distance to total time. Here we are considering distance. Just save it in your mind. It is the ratio of total distance to total time taken. That means average speed is equal to total distance divided by total time. Now it's time for average velocity. Average velocity. Average velocity is the ratio of total displacement to total time taken. That is, total displacement divided by total time gives the average velocity. Here we can write average velocity equal to total displacement divided by total time. This is what average velocity is. Just underline the term total displacement to total time. In average speed, we are taking total distance and total time. But here we are taking total displacement and total time. Average velocity is the ratio of total displacement to total time. That is, average velocity can be written as average velocity equal to total displacement divided by total time. That's the difference between average speed and average velocity. When you are getting a question or a problem related to average speed and velocity, just look carefully. Was it average speed or average velocity? If you are asking to find the answer for average speed, then you have to find the total distance and total time. If you are asking to find average velocity, then you have to find the total displacement. Don't be confused. For average velocity, we need total displacement, and for average speed, V needs total distance. This is the difference between average speed and average velocity. Now we are moving to the most important section of this chapter, motion. One of the most important, very important, and surely you are having questions from the topic I'm going to deliver now. This is related to graph. Surely you are having questions from graph. We are having three graphs: position time graph, velocity time graph, and acceleration time graph. Among these three, first two, position time graph and velocity time graph, is very important, and you get a sure short question from that topic. Now just recollect what we have learned and moving to the next topic, position time graph. From the name itself, you are clear that what are the terms we are representing in the graph. We are having two terms, position and time. These two terms are representing in the graph. Basically, you all know the character of a graph. We are having two axes. Actually, we are having three axes, x, y, and z. We are having position and time. That means two coordinates is required for representing these two terms. Therefore, I am taking only x and y axis. This is x axis and this is y axis. The abscissa and the ordinate. You already knows that the abscissa and the ordinate, the x and the y axis. In x axis, we are representing the time. In y axis, we are representing the position. Then from the values of position and time, just we plot a graph. Thus the graph we get is the position time graph. The reference quantity is marked in the x-axis. In motion, we already said that the reference quantity is time. On the basis of time, we are explaining all terms related to motion. Therefore, here also the reference quantity is time, and that is why I am representing time in the x-axis and position in the y-axis. From the values of position and time, we plot a graph just representing the position and time. A, B, C, 3 points. Just for an example, we are having 3 points, then we plot a graph like this. Then this is the position time graph. I marked the points A, B, C just for an example from the values of position and time. If this is the position and this is the time value, and that's our point. Like this. From the table. In the problem, you are having the table for values of position and time. Just look at the table and just plot the points like this. Then we got the position time graph. Now we can define what a position time graph is. A graph plotting with time along x-axis and position along y-axis is called a position time graph. A graph plotting with time along x-axis. You know that time is the reference quantity. That's why we are plotting it in x-axis. And the other term position in the y-axis. Then the graph is called position time graph. a graph plotting with time along x-axis and position along y-axis. A graph plotting with time along x-axis and position along y-axis is called a position time graph. This graph has lots of nature. We have to find the nature of the graph. That means in graph we can have straight line or curve or line parallel to the x-axis. For all these, we have to define the nature of the graph. That means define the motion of the object from the graph. Then we have to find the slope of the graph. From the slope of the graph, we get a tape that we are already studied. Now we have to derive which term we are getting from slope of the graph. Okay, moving to the nature of the position time graph. We know that graph plotting with time along x-axis and position along y-axis is called a position time graph. Now moving to the nature of the graph, nature of position time graph. First one, I'm just drawing a graph, time along x-axis, position along y-axis. If we get a graph like this, that is a straight line parallel to the time axis. That means a straight line parallel to the x-axis. From this graph, it is clear that the position of the object is does not changing. It is in a fixed position. That means we represent the position in y-axis. If the value changes, the graph may increase or decrease, upward or downward. But here the graph is parallel to x-axis. That means the position is fixed. The nature of the graph is the object is at rest. If you are asking a question that draw a graph, draw a position time graph where the object is at rest, then you can draw like this. The nature of the graph is object at rest. This is the first nature. From position time graph, if we get the graph parallel to the x-axis, then the nature is at rest, object at rest. Then the second one, I'm drawing a position time graph, time along x-axis, position along y-axis. If we get a graph like this, a straight line starting from the origin. If we get a graph like this, a straight line starting from the origin, the nature of the graph is object is in uniform motion. Object is in uniform motion. Or we can say that object is moving with uniform velocity. Since the graph is an increasing one, it is an increasing one, uniform velocity having positive value. Uniform velocity having positive value. This is the second nature of the graph. If we are getting a graph starting from the origin and a straight line, then the nature of the graph is object is moving with uniform velocity having positive value. Then the third one, third nature, showing a graph, time along x-axis and position along y-axis. If we get a graph like this is also a straight line. This graph is also a straight line. But look at this graph. This is a decreasing graph. Here it is an increasing graph from bottom towards up. That means starting from the origin and going upwards. But here it is starting from the top and going downwards. This is a decreasing graph and a straight line. If we get a decreasing straight line graph, then the nature of motion is also uniform motion. It is also uniform motion. That means straight line representing in position time graph gives the nature as uniform motion, or we can say that the object is moving with uniform velocity. But one thing to be noted here, that this is a decreasing graph, therefore value is negative. Uniform velocity having negative value. Uniform velocity having negative value. This is the third nature of graph. And the fourth one, I'm drawing another graph. Time along x-axis and position along y-axis. And we are having a curve, not a straight line. We are having a curve. If we are getting a curve, then the nature is non-uniform motion. Then the nature is non-uniform motion. Or we can say that object is moving with non-uniform velocity. Object is moving with non-uniform velocity. Look at these four graphs. These are very important. First one, if we get a graph parallel to the x-axis, then the object is at rest. If we are getting a straight line starting from origin, that is an increasing graph, then the nature is uniform motion, or object is moving with uniform velocity having positive value. If the graph is a straight line and is a decreasing from starting from the top and going towards bottom, then the nature is uniform motion, or we can say the object is moving with uniform velocity, but it is a decreasing graph, therefore having negative value. If we get a graph in a shape other than these three, if we get a graph in a shape other than these three, that is parallel to x-axis, straight line starting from origin, or straight line that is of decreasing form. Other than these three forms are non-uniform motion. That means if we get a curve, not a straight line, we get a curve. Any curve we are getting from position time graph is non-uniform motion, or we can say that object is moving with non-uniform velocity. Very, very important topic. Please understand the four natures of the position time graph. Just free up your mind and store it, because we are having same graph in velocity time graph. Then you may be a bit confused. So just by heart it right now. The last topic of position time graph is the slope of the position time graph. The slope of position time graph. The slope of position time graph gives The slope of position time graph gives a term. I'm not written now. We have to find this term and then we can fill the blank space. The slope of position time graph gives dash. I am considering a position time graph, time along x-axis and position along y-axis. I am just taking the graph, the straight line starting from origin. Now we have to find the slope of the graph. We have to find the slope of the graph. You already know that how to find the slope in your mathematics chapter. In mathematics, you are studying how to find the slope of a line. We can find the slope of a line simply by taking tan theta. If we are marking the angle theta here, then tan theta gives the slope of the line. Otherwise, we are having another equation for finding slope. Slope is equal to y2 minus y1 divided by x2 minus x1. That means just consider a small rectangle, small triangle in this portion of the graph. I am considering this and naming as A, B and C. We are having equation slope equal to y2 minus y1 by x2 minus x1. That means the difference between the y values, these are the y values, y2, y1 by x2 minus x1, the difference between x values. These are the x values, x2, x1. Therefore, slope is equal to, just look at this graph, y2 minus y1. We are representing position in the y-axis. Therefore, y2 minus y1 will always give us position. Simply, it's a distance. Position simply, it's a distance. By x2 minus x1. x2 and x1 are marked in the time axis. Therefore, the difference between x2 and x1 always gives time. That is by time. Now we get distance by time. We already know this term. Distance by time. It's speed. If the object is traveling in a straight line, then distance and displacement are same. Therefore, we can write velocity also. Then slope of the position time graph gives speed or velocity. We are considering this straight line. This straight line represents object is moving with uniform velocity. That is, object is moving with uniform velocity represent, that is in uniform motion. If it is in uniform motion, then the slope of the graph gives speed or velocity. Now we can fill up the blank space as the slope of position time graph gives velocity or speed, no problem. The slope of position time graph gives velocity. Look how we derive the term. We can find the slope by taking the equation y2 minus y1 by x2 minus x1. In y-axis, we are representing position. Therefore, y2 minus y1 will give us position. That's simply a distance by x2 minus x1. x2 minus x1 is in the time axis. Therefore, x2 minus x1 will give us time. Then distance by time is speed. Or simply y2 minus y1 can also be written as displacement. Therefore, displacement by time will give us velocity. That means slope of position time graph gives speed or velocity. I'm writing velocity in the blank space. The slope of position time graph gives velocity. Now we solve the case and we get the term velocity. That's all about position time graph. Now we are moving to our next graph, velocity time graph. velocity time graph. In position time graph, we define it as a graph plotting with time along x-axis and position along y-axis. We already know that time is our reference quantity. In this chapter, for explaining motion and the terms related to it, we are taking time as the reference quantity. Here in velocity time graph also, our reference quantity is time. Therefore, in the graph, we represent time in the x-axis and velocity in the y-axis. Like this, we represent time in the x-axis and velocity in the y-axis. Then we get the velocity time graph. Then we get the velocity time graph. Just having the values of velocity and time from the table we are having in the problem, just plot points like this and draw a graph. This is the velocity time graph. For problems, we are having values for velocity and time just in a table. In the question paper, it is already given the values of velocity and time in a table. And using that table, we have to draw the velocity time graph. Now we can define the velocity time graph as a graph plotting with time along x-axis and velocity along y-axis is called a velocity time graph. A graph plotting with time along x-axis and velocity along y-axis is called velocity time graph. A graph plotting with time along x-axis and velocity along y-axis is called a velocity time graph. Similar to what we have done in position time graph. Here also, we have to find the nature of velocity time graph. Moving to the nature, how we draw different type of velocity time graph according to the nature of the motion of an object. First one, I'm drawing a graph with time along x-axis and velocity along y-axis. If we are getting a graph like this, that means a straight line parallel to the x-axis or a straight line parallel to the time axis. This means that in position time graph, a graph like this means the object is in rest. But listen carefully, in velocity time graph, a graph like this doesn't mean that the object is in rest. This means that, look, velocity is plotted in the y-axis. It's a straight line parallel to the x-axis. Therefore, it means that y values are not changing. Y value means velocity. Velocity is not changing. That means it is constant. The nature of the motion is uniform velocity. Object is moving with uniform velocity. If you are asking to draw a graph of uniform velocity using velocity time graph, then draw like this. If you are asking for draw uniform velocity using position time graph, then you have to draw a straight line starting from origin. Now moving to the second nature, I'm drawing a graph with time along x-axis and velocity along y-axis. If we get a straight line like this, we get a straight line like this, then the nature of the graph is the object is moving with uniform acceleration. The object is moving with uniform acceleration. Since the graph is an increasing one, starting from the bottom or starting from the origin towards the top, then the value is positive. If we get a graph like this, that means it is a straight line starting from the origin, then the nature of the graph is uniform acceleration. Now you have a confusion that what this term is acceleration. After our graph, we are explaining what acceleration is. After this topic, we are after completing our graph, I explain what acceleration is and how we can define acceleration. Now, just listen carefully to the graph. In velocity time graph, if we are getting a straight line starting from origin, then the nature of the graph is uniform acceleration. Since it is an increasing one, it is positive value. Now moving to the third one. Time along x-axis and velocity along y-axis. We get a straight line like this, but this is a decreasing graph starting from the top and going downwards. The nature of this graph is uniform retardation. Uniform retardation. Now again you are confused with the term retardation. Retardation simply means negative acceleration. Whenever the acceleration becomes negative, then it is called retardation. We are explaining this term also after our graph. Next, we are going to the fourth one. Time along x-axis and velocity along y-axis. If we are getting a curve like this, any curve in the graph, it represents non-uniform acceleration. Non-uniform acceleration. These are the four natures of the graph. Listen to the graph, velocity time graph. If we are getting a straight line parallel to the x-axis, that is the time axis, then the nature of the graph is uniform velocity. If we are getting a straight line starting from origin, then it is uniform acceleration. Need not to be right positive here because acceleration is always positive. If it becomes negative, then it is called a retardation. If we are getting a decreasing graph, a straight line too, then the nature is uniform retardation. A graph other than these three, like any curve, it is non-uniform acceleration. This is the nature of velocity time graph. Now we have to find the slope of velocity time graph and area of velocity time graph. We can find it one by one. Like what we did in position time graph, here also slope of velocity time graph gives dash. We are getting a term. We have to find the term. Just using the graph, we can find the term and then fill in the blank space. I am just considering a graph, time along x-axis, velocity along y-axis, a straight line starting from origin. We already know how to find slope. Slope of a line is y2 minus y1 by x2 minus x1. That is equal to, consider a small triangle, points are A, B, C. This is the y2 value and this is the y1 value. And in the x-axis, this is the x2 value and this is the x1 value. Y2 minus y1 means difference in the values of y-axis. In y-axis, we are representing velocity. Therefore, y2 minus y1 always gives the value of velocity divided by x2 minus x1. x2 minus x1. x2 minus x1 means these x2 and x1 are in time axis. Therefore, difference in time value, x2 minus x1 will give time. And we are having velocity by time. Velocity by time gives acceleration. This is the equation for acceleration. And we are explaining the term as well as equation after completing the graph. Therefore, slope of velocity time graph gives acceleration. Slope of velocity time graph gives acceleration. Now we have to find the area under velocity time graph. That also gives us a term, area under velocity time graph. Area under velocity time graph is dash. Here also we are getting a term, and first we have to find the term and then we can fill the space. I'm considering a graph, time along x-axis and velocity along y-axis. I'm taking the graph like this, a straight line parallel to the x-axis. This is more comfortable to derive which term we are having from area. Now look, we have to find the area under this curve. That means this area. We have to find this area. Now we got a rectangle here. Look, area under the graph is in the shape of a rectangle and naming it as A, B, C and D. I'm going to find the area of a rectangle A, B, C, D. How to find the area of a rectangle? You know that to find the area of a rectangle, we have to multiply its length and breadth. Therefore, area of a rectangle is length into breadth. Length into breadth. That is equal to, here the length is AB or CD and the breadth is AD or BC. AB, look, this is AB, that is this length. The C to D length, this is in the x-axis, and AB representing time into AD. This is the AD value. This is in y-axis, and AD represents the value of velocity. We get time into velocity. What is time into velocity? We are having equation velocity is equal to displacement by time. Therefore, time into velocity gives displacement. Time into velocity gives displacement. That means area under velocity time graph gives displacement. Area under velocity time graph gives displacement. Now we've gone through velocity time graph. Next, we have to explain what the term acceleration is and retardation is. Then we must go through acceleration time graph. That's all about velocity time graph, and I am moving to the next topic, acceleration. Our next topic is acceleration, represented by the letter small letter a. Acceleration is represented using the small letter a. Acceleration is defined as the rate of change of velocity, or we can say that acceleration is equal to velocity divided by time. Rate of change of velocity is called acceleration. That means the rate at which velocity is changing. That's what called acceleration. In gravitation, you are studying acceleration due to gravity. It is having value 9.8 meter per second square. That means velocity is changing at the rate of 9.8 meter per second square. If an object is having 2 meter per second square acceleration, it is meant that the object is changing its velocity at the rate of 2 meter per second. If it is changing at the rate of 2, then acceleration is 2 meter per second square. Therefore, acceleration can be defined as the rate of change of velocity. Acceleration is defined as the rate of change of velocity. Then we can write acceleration as acceleration is equal to change in velocity divided by time. Change in velocity divided by time. Acceleration is represented by the letter A. Therefore, we can write A is equal to change in velocity. How we find the change in velocity? We can find the change in velocity by subtracting initial value from the final value. That means always we get the change when we subtract initial from the final. For change in velocity, final value minus initial value. That means final velocity minus initial velocity gives change in velocity. Therefore, A is equal to final velocity minus initial velocity divided by time is represented by the letter T. Time is represented by the letter T. That is, A is equal to, if we represent final velocity as V minus initial velocity as U, then we can write the equation as A is equal to V minus U by T, where V is the final velocity and U is the initial velocity. Remember the terms, V is the final velocity and U is the initial velocity. A acceleration and T is the time. Therefore, acceleration A is equal to V minus U by T. It is the rate of change of velocity. Rate simply means divided by time. Then SI unit of acceleration. We can find the unit using this equation V minus U. That means change in velocity. That's velocity term. Unit of velocity is meter per second divided by time. The unit of time is also second. That is meter per second by second. That is meter per second square. Meter per second by second is meter per second square. Unit of acceleration is meter per second square. This is acceleration. The term is used in velocity time graph. The term acceleration we are used in velocity time graph. That means in velocity time graph, if the graph is a straight line starting from origin, then we say that the object is moving with uniform acceleration. Now you understand what acceleration is. It is the rate of change of velocity. A is equal to V minus U by T. Unit of acceleration is meter per second square. If we study acceleration, then we must study retardation also. Retardation or deceleration. Remember the two terms, retardation or deceleration. Retardation or deceleration. In the starting of the chapter, we already give the example of vector quantity as acceleration. That means acceleration is a vector quantity. It is having magnitude as well as directions. That means it can have zero, positive or negative values. Whenever the acceleration becomes negative, it is called as retardation or deceleration. Whenever the acceleration becomes negative, it is called as retardation or deceleration. That means negative acceleration is called negative acceleration is called negative acceleration is called retardation or deceleration. Negative acceleration is called retardation or deceleration. Negative acceleration is called retardation or deceleration. That's all about acceleration and retardation. Now we are moving to the last type of graph. We already discussed about position time graph and velocity time graph. Now we are going to the last type of graph, acceleration time graph. Acceleration time graph. Like what we have done in position time graph and velocity time graph, if we are plotting a graph and representing the reference quantity time in x-axis and acceleration in y-axis, then we got the graph acceleration time graph. That means the graph plotting with time along x-axis, plotting with time along x-axis and acceleration along y-axis. A graph plotting with time along x-axis and acceleration along y-axis is called an acceleration time graph. Like this, time along x-axis and acceleration along y-axis. Then it is called acceleration time graph. We are having only two natures for this graph. You need to be study only two. Like in position time graph or in velocity time graph, we are having four types of graphs. Here only two types of graph. First one is I'm plotting a graph with time along x-axis and acceleration along y-axis. If we get a graph like this, that is a straight line parallel to the time axis, a straight line parallel to the x-axis. Here the y values are not changing, y value is a constant. In y-axis, we are representing acceleration. Therefore, we can say that the nature of the graph is uniform acceleration. Uniform acceleration. A graph other than this, a graph other than this type, like starting from origin or a curve or a decreasing or increasing, any type other than this is non-uniform acceleration. I'm plotting a graph with time along x-axis and acceleration along y-axis. We are getting this like this, or if we are getting like this, or if we are getting a curve. Anyway, the graph other than this type can be called as non-uniform acceleration. Non-uniform acceleration. That's the acceleration time graph. Acceleration time graph simply means graph plotting with time along x-axis and acceleration along y-axis. We are having only two types of graphs here. One is a straight line parallel to the time axis that represents uniform acceleration, and other than this type, like parallel to the x-axis. Other than this type is non-uniform acceleration, that may be a straight line starting from origin or a decreasing one or a curve. That's all non-uniform acceleration. Now we discussed the three types of graph: position time graph, velocity time graph, and acceleration time. That's all about the graph: position time graph, velocity time graph, and acceleration time graph. Now you just recollect what we have studied in the graph section. Now you have completed the graph. position time graph, velocity time graph, and acceleration time graph. Then we are moving to the section equations of motion. You have to derive it from the graph. Using velocity time graph, you have to derive the equations of motion. We are having three equations. Just I am writing the three equations first, then going to derive it from the graph. First one is V is equal to U plus AT. This is the first equation of motion, and this is called as velocity time relation. This is called as velocity time relation. And second equation of motion is S is equal to ut plus half at square, where S is the displacement, U initial velocity, and T is the time. This is called position time relation. And the final one, third equation of motion is V square is equal to U square plus 2S. And this is known as velocity position relation. Velocity position relation. These are the three equations of motion. We have to derive these three from a velocity time graph. We are using a velocity time graph and deriving these three: velocity time relation, position time relation, and velocity position relation. Now I am drawing a graph for deriving these three equations. Just consider a velocity time graph. I am drawing it a bit larger because we have to mark some terms in the graph. This is our graph. Time along x-axis and velocity along y-axis. Graph is not starting from the origin. The graph is starting from here. That means these values the initial velocity. And I just name the graph as A and B. This is the origin of the graph represented as O. Taking this letter as C. Look, this BC is the final velocity. This BC is the final velocity. And this OA is the initial velocity. And this OC, O2C, this is time T. And I'm drawing another more line, A, B, C, and D. This is also time because OC is time T. Then it is same as AD. This is our required graph. From this graph, I am deriving the three equations of motion. I am deriving the first one from the graph. Look at the graph. We are having values OA is equal to initial velocity U and BC is the final velocity V, and OC is time, AD is time. This is the graph. From this graph, I am just taking BC. From this graph, I am just taking BC. BC can be written as, look at the graph, BC can be written as BD plus CD. or CD plus BD. Like anyway, BC can be written as, that means this BC is split up into two, BD and DC. Therefore, I am writing this as BC is equal to CD plus BD. We know that BC is B. BC is V. Substituting BC as V is equal to CD is U. Look, CD and OA are same. Therefore, CD can be written as U plus BD. We are not having the value BD. We don't know what BD is. I'm just shifting this U from right side to left side, then it becomes negative and can be written as BD is equal to V minus U. Put it as equation number 1. Now from the definition of acceleration, we have A is equal to V minus U by T. We have A is equal to V minus U by T. Just cross multiplying the term, we get AT is equal to V minus U. Put it as equation number 2. Just compare this equation 1 and 2. Comparing equation 1 and 2. Equation 1 is BD is equal to V minus U. And equation 2 is AT is equal to V minus U. In both equation 1 and 2, the right hand side is same. RHS is same, that is V minus U. In first equation, the LHS is BD, and in second equation, LHS is AT. If the equations having same RHS, then LHS must also be same. We are having right hand side as V minus U, therefore left hand side should be same. Therefore, we can write from equation 1 and equation 2. From equation 1 and equation 2, we get BD is equal to AT. Simply we got the value as AT. That means BD is same as AT. BD is same as AT. Just substituting the value to equation 1, we get V minus U is equal to AT. Just substitute the value of AT in equation 1, then we get V minus U is equal to AT. Just shift the minus U to the right hand side, then it becomes positive. Then we can write V is equal to U plus AT. This is equation number 1. This is equation number 1 and is called velocity time relation. This is the first equation of motion. We just derive it from the graph. V is equal to U plus AT, and this is called velocity time relation. Now we have to derive the second equation from the same graph. From the same graph. Therefore, I am not rubbing the graph. I just rub it after deriving 3 equations. Moving to the second equation. Just note a point from here. From the first equation, note a point. We are having value BD is equal to AT. Just remember that value. We can use it in other 2 equations. BD can be replaced by AT. The substitute of BD is AT. We can substitute BD using the value AT. So don't forget that value. Just remember it. BD is equal to AT. Now we have to derive the second equation. Now I am going to derive the second equation. Now look, we already discussed about the velocity time graph, and we know that area under velocity time graph gives displacement. We know that area under velocity time graph gives displacement. That is the condition I am going to use here. Area under velocity time graph gives displacement. This is the condition we are going to use here. Area under velocity time graph gives displacement. Therefore, we have to find the area under this graph. That means the area of A, B, C, O, A. That is in the shape of a trapezium. That is in the shape of a trapezium. We have to find the area of trapezium. A, B, C, O, A. That's the trapezium. Area of trapezium A, B, C, O, A is equal to. I am just splitting this trapezium into two. AOCD is a rectangle and ADB is a triangle. If we find the area of rectangle and triangle separately and then add, we get the area of trapezium. Therefore, I am splitting the trapezium into two. Area of trapezium ABCOA as area of rectangle AOCD plus area of triangle ABD. This area of rectangle plus area of triangle gives area of trapezium. That is what we need. Therefore, area of trapezium is equal to area of triangle, area of rectangle AOCD plus area of triangle ABC. I am finding it separately. First, I am finding area of rectangle AOCD is equal to, we already knows that length into breadth always gives area of rectangle. That is equal to length of the rectangle is AD into breadth of the rectangle is AO. That is equal to, we already knows that AD is T and AO is U. That is equal to T into U and can be written as UT. Now we get the area of rectangle. Now we have to find the area of triangle ABD. Area of triangle ABD is equal to find the area of triangle, the equation is half into base into height. That is half BH. Half into base into height. That's the equation for finding area of a triangle. Half into base into height. That is equal to half into, look at this triangle ABD. What's the base? AD is the base. Half into AD into height. What's the height? BD is the height. That is equal to half into AD. What is AD? That's T into BD. I just said to remember the term BD. We are having the value BD is equal to AT from the first equation. That is BD can be replaced as AT. That is equal to half into T into AT. This can be written as half AT square. Now we got the area of rectangle and area of triangle. When adding these two, we get the area of trapezium ABCOA. The area under the graph gives displacement. We know that the area under velocity time graph gives displacement. Therefore, area of trapezium ABCOA is the displacement. And the displacement is denoted as S is equal to area of rectangle already found UT plus area of triangle half at square. Look, this is the second equation of motion. S is equal to ut plus half at square. This is the second equation of motion and is called as position time relation. It is called as position time relation. This is the second equation. How we derive the second equation? We are just taking the area under the graph. Area under the graph always gives displacement. The area under the graph is in the shape of a trapezium. For finding it, I just split the trapezium into two, a rectangle and a triangle, and separately find the area of rectangle and triangle. Then we add it to get the total area. That's the equation. S is equal to ut plus half at square, and this relation is called as position time relation. Now we have to derive the third equation of motion from the same graph. Therefore, I am not rubbing it now. I am using the same graph to derive the third equation. For third equation of motion, we are using the same condition. Area under velocity time graph gives displacement. That means the area under the graph is in the shape of a trapezium. Therefore, we are going to find the area of trapezium, but in another way. For second motion equation, we are finding the area by splitting the trapezium into two, a rectangle and a triangle. But now I am not splitting it into two. I am just giving the equation to find the area of trapezium. Actually, you already know that how the area of trapezium is to be found out. Area of trapezium is, the equation is half of h into a plus b. If you don't know the equation, then I can explain the terms half of h into a plus b. The term h means height. That is the distance between two parallel sides. You know the feature of a trapezium. For a trapezium, it's having a pair of parallel sides. One pair of parallel sides. Here, AO and BC are the pair of parallel sides. The distance between this parallel side is taken as the height of the trapezium H, and A and B are the length of the parallel sides. Here AO and BC are the parallel sides. Therefore, small letter a and represents the length of AO and BC. That is, area of trapezium always gives here area under the graph. Area under the graph is in the shape of trapezium. Therefore, that area gives displacement. Displacement is denoted as S. Therefore, S is equal to half into H means the distance between these two parallel sides. That is AD or OC. We can take AD or OC into A plus B. A and B are the lengths of parallel sides. Here AO and BC are the parallel sides. AD into AO plus BC. That is, S is equal to half into AD is T into AO plus BC. AO is U plus BC is B. Just substitute all the values, we get S is equal to half into T into U plus B. Now just listen. I am giving another substitution from equation number 1. From first equation of motion. We are having V is equal to U plus AT. Therefore, V minus U is equal to AT and T is equal to V minus U by A. Look, we got a substitution for T as T is equal to V minus U by A. This is important. Remember this substitution, T is equal to V minus U by A. Just substituting this value in this equation in place of T. In S is equal to half into T into U plus V. I am substituting the T by V minus U by A. Therefore, we can write S is equal to half into substituting T by V minus U by A into U plus V. Now S is equal to half into V minus U by A into U plus B. You know that A plus B is equal to B plus A. For addition, A plus B and B plus A are same. Therefore, I can write U plus B as B plus U. Therefore, S is equal to half into, look at the denominator, sorry, look at the numerator, V minus U into V plus U. That is A minus B into A plus B. A minus B into A plus B is A square minus B square. A plus B into A minus B or A minus B into A plus B is A square minus B square. That's standard result. Therefore, V minus U into V plus U. V minus U into V plus U can be written as V square minus U square divided by A. Then by combining 1 into V square minus U square, we can write V square minus U square by denominator 2 into A, 2A. Therefore, S is equal to V square minus U square by 2A. I am rubbing this and completing the remaining section. Now look, S is equal to V square minus U square by 2A. I'm just cross multiplying 2A to this side. Then it becomes 2AS. 2AS is equal to V square minus U square. Then I'm shifting this minus U square to the other side. Then it becomes plus U square. That is 2AS plus U square is equal to V square. On rearranging this, we get V square is equal to U square plus 2AS. This is the third equation of motion. V square is equal to U square plus 2AS. This is the third equation of motion and we call it as velocity position relation, and we call it as velocity position relation. Now we derive three equations of motion from the same graph. A very important topic. You are having problems from using this equation. You are having questions to derive any one relation. Velocity position relation, velocity time relation, or position time relation. Any one question from the graph. Using the graph, you have to derive any one equation. And using this equation, you have to solve problems also. That's all about equations of motion. And now we are moving to the final section of our chapter. Final theoretical section of the chapter, circular motion. And that is the last section of our chapter theoretically. And after that, we have to solve some problems. Previously asked questions or the questions which we are expecting to ask in the exam, board exam for you. So After completing the last theoretical section, we are going through some problems also. And the last topic is circular motion. Circular motion simply means if an object is traveling along the circumference of a circle. That means if an object is traveling along the path of a circle, the moving path is in the shape of a circle, then the motion is said to be circular motion. If an object is traveling along the circumference of a circle, then the motion is said to be circular motion. If an object is traveling along the circumference of a circle, if an object is traveling along the circumference of a circle, then the motion is said to be circular motion. That's what called circular motion. That means an object is traveling along the circumference of a circle, or the path of the object is in the shape of a circle. Then the motion is said to be circular motion. We are having one more topic that's related to circular motion, not a new topic. That's same from the topic circular motion, uniform circular motion. Uniform circular motion. If an object executing circular motion having constant speed or uniform speed, then the motion is said to be uniform circular motion. If an object traveling along the circumference of a circle with constant speed or uniform speed, then it is called uniform circular motion. If an object moves in a circular path, if an object moves in a circular path with constant speed, with constant speed, then it is called uniform circular motion. In uniform circular motion, one point to be noted is that, one important point to be noted is that you are having a question in your board exams that can an object or can a body having constant speed but acceleration, can an object having constant speed but acceleration? Surely your answer is no, because we already said that rate of change of velocity is called acceleration. That means only velocity changes, acceleration happens. But here the question is, can a body have constant speed but acceleration? A body having constant speed and acceleration too. I know you already answer it as a big no. This is your answer. But listen carefully that in uniform circular motion, the speed is constant, but we know that velocity is a vector quantity. That means velocity having magnitude as well as direction. If direction changes also, it is also a change. Direction changes, it's also a change and can have acceleration. Here, if we want to find the direction in a circular motion, we have to draw a tangent. That means in this point, the direction of velocity is like this. We are taking another point, the direction is like this. And if we are taking another point, the direction is like this. Look, these 3 points, direction is not same. That means in circular motion, the direction of the object is changing at every point. At every point, the direction is changed. The magnitude only remains constant. That means the magnitude value only remains constant. Direction is continuously changing. Therefore, this object can have acceleration. This object can have acceleration. Now you can answer the question. Can a body have constant speed but acceleration? Yes, a body can have constant speed but acceleration in uniform circular motion. In uniform circular motion. That's all about circular motion and uniform circular motion. This is the last topic of our first chapter, motion. This is the last theoretical topic. Now we have to solve some problems which were previously asked or we are expecting to ask in your board exam. We have to solve some problems also. This is the last topic. Just recollect what we have learned in the theoretical portion and get ready for solving some problems. Then the next section is our problem section. Now we just complete the theoretical portions of first chapter, motion, and we are going to explain a problem in this chapter. I'm explaining only one problem, then remaining we can explain in the last section of all our chapters are completed. Now look at this problem. A train starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. From this problem, it is clear that the term we have to find is acceleration. Now read again the question. A train starting from a railway station. A train starting from a railway station. A vehicle or a train starting from a railway station or starting from any point. Then initial velocity should be taken as 0. Initial velocity should be taken as 0. Any vehicle starting from a point, then initial velocity is taken as 0. With a uniform acceleration attains a speed of 40 km per hour. Here the train is attaining a speed of 40 km per hour. Therefore, final velocity V is 40 km per hour. We have to convert this to meter per second because the standard unit of velocity is meter per second. Here in this problem, it is given in kilometer per hour. Now I am going to convert this kilometer per hour into meter per second. That is 40 into, we know that 1000 meter makes 1 kilometer. Therefore, to convert kilometer to meter, multiply it with 1000 divided by hour to second. We have 60 minutes make 1 hour and 60 seconds make 1 minute. Therefore, in denominator, we have to multiply 60 into 60. That is V is equal to, we have to cut the zeros in numerator and denominator, cut. Then 100 into 4, 400 divided by 6 into 6, 36. Okay. This is the velocity in meter per second. We can simplify it. 200 by 18 and 100 by 9 meter per second. Okay. Now time is given that time t is equal to 10 minutes. It is in minute. We have to convert this also in seconds. That is 10 into 60 is equal to 600 seconds. Now look, we are having values v, u, a and t. Which is the relation connecting these four terms? The first equation of motion, that is v is equal to u plus at. Substituting the values, we are having value v is equal to 100 by 9 is equal to u0 plus, we have to find acceleration into time t 600 seconds. Okay, then 100 by 9 is equal to 600 a. I'm cross multiplying. 100 is equal to 9 into 600. It's 5400 a. Therefore, acceleration a is equal to 100 by 5400. This a is equal to 1 by 54 meter per second square. Look once more in this problem. Here a train is starting from a railway station. Therefore, I take u is equal to 0 and attains a speed of 40 kilometer per hour. We have to convert this kilometer per hour to meter per second. To convert kilometer per hour to meter per second, multiply it by 1000 by 3600. That is, simply multiply it with 10 by 36. That is 40 into 10 by 36. That is 400 by 36. When simplifying, we get divided by 2, 400 by 2, 200, 36 by 2, 80. Again, simplifying by 2, 200 divided by 200, 18 divided by 2, 9. That is 100 by 9 meter per second. Time is given in minute, 10 minutes. I just converted it to seconds, 10 into 60, 600 seconds. The relation connecting the terms are v is equal to u plus at, and just substituting the value. V is 100 by 9, u is 0. We have to find a, and t is 600 seconds. That is 600 a is equal to 100 by 9. Just cross multiplying it, we get 100 is equal to 600 a into 9. 9 into 6, 56. Therefore, 5400 a. Therefore, a is equal to 100 by 5400. That is 1 by 54 meter per second square. This is the acceleration attained by this train. I think it's clear how to solve this problem. That's all about our first chapter, motion. Let us have a recollect what we have studied in this chapter. That is a revision of the chapter or a recap of our lesson. I'm just telling the important topics in this recap, and you must study the things we have explained in this recap sections. Therefore, in this chapter, the motion, the important topics we explained are, first one is motion and rest. That is concept of motion and concept of rest. Second one is scalar quantities and vector quantities. Third one is distance and displacement. Fourth one is uniform motion and non-uniform motion. Fifth is speed and velocity. Sixth one is average speed and average velocity. Then seventh one is acceleration and retardation. Acceleration and retardation. And eighth one is graph. graph, we are having three graphs. Position time graph. Second one is velocity time graph. Third one is acceleration time graph. Then ninth topic is equations of motion. We are having three equations. V is equal to U plus AT. S is equal to UT plus half AT square. And V square is equal to U square plus 2AS. And the last topic is circular motion. This is what we have studied in the first chapter, motion. Grade 9 CBSE, first chapter, motion. We have 10 topics. You must study these 10 topics clearly. Then you can simply answer any question from the first chapter. These are all we explained in our first chapter. That's all about our first chapter. This is all about our first chapter. Just try to recollect these 10 topics. You will surely answer all the questions from this chapter. Now we have completed the first chapter physics, first chapter motion. I am Nidishas and thank you for joining me in this section, and we will meet you in the next section. Bye bye.